Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hello, my name is Suzanne Miller. I'm a principal researcher here at the SEI, and today I would like to welcome my colleagues, Dr. Douglas Post and Dr. Richard Kendall. Since 1975, Doug has initiated and led programs to develop and apply supercomputer modeling and simulation software for engineering, design, and scientific research at many places, including Princeton Plasma Physics, Lawrence Livermore Labs, Los Alamos Labs, and the DoD. Dr. Richard Kendall is a software engineering consultant with the DoD High Performance Computer Modernization Program, otherwise known as HPCMP. He has more than 50 years of experience in applications of computational mathematics to engineering problems. Today, we're here to talk with both of them about their book on creating software for virtual prototypes. The title of the book is Creating and Using Virtual Prototyping Software Principles and Practices by Douglas Post and Richard Kendall. The book is based on their extensive career experience and is especially informed by their experiences in CREATE, a multi-year DoD program to develop and deploy software to create digital siblings for systems like ships, air vehicles, ground vehicles, and RF antennas, and to enable engineers and scientists to design these complex systems and to accurately predict their performance. Welcome to you both. That's quite an introduction. I don't usually have that long of an introduction for people, so you guys have been around a lot longer than some of the folks we talked to. Welcome. All right, so do you mind if I call you Richard and Doug? Is that all right?
That's fine.
That's fine.
Perfect. So let's start off by having you each tell us a little bit about yourselves and the work that you do that led to this book. So Doug, let's go ahead and start with you, and then we'll follow with Richard.
Okay, well, I've had a career doing this. I started with a PhD in physics. It's an experimental and theoretical physics at Stanford, and then I've been using supercomputers, as you mentioned, at PPL and ITER, which is a large fusion experiment that's being built in Carnegie in France, and I've led groups at Livermore and Los Alamos, and started the project at Princeton. At the Department of Defense called CREATE, and also an affiliation with the SEI. Richard.
Well, my career also started right after a PhD at Rice University in numerical analysis, and it's been dominated by the theme of applying computational mathematics to engineering. It also has had three phases, starting with an industry phase at ESSO, now ExxonMobil. We didn't use the term supercomputer back then, and we wouldn't have called any computer we had access to a supercomputer. ExxonMobil was followed up with a phase in a startup. It was a venture to develop what we would now refer to as virtual prototyping software for the international oil industry. And we did have supercomputers then, Cray-1, Cyber 205. And then finally, a government phase, first at Los Alamos National Lab in geosciences and then IT. I was the first CIO there. And then now with CREATE for the last more than 16 years as a software engineering consultant. We're certainly in the supercomputer era now. We just entered the exascale era. So it's been a long ride.
So both of you have seen a lot of evolution in the computing field, not just in terms of the work that you're doing, particularly with virtual prototyping, but software engineering methods and our ability to actually apply computer science to these very complex problems. So lots of places you could have gone different directions. What was the catalyst for the CREATE work, and how did you two begin to work together on this virtual prototyping software project?
Well, I'll start this. I think back in 2005, when Create started, the stars were aligned for it, so to speak. First, the Department of Defense desperately needed to find ways to speed up development of major weapon systems. Second, there had been by that time exponential growth in the capability of supercomputers. Due to good old Moore's law, kept doubling every year and a half or so. And Doug recognized that virtual prototyping with supercomputers could meet this objective of speeding up the acquisition cycle. And in particular, both of us had already met each other in the Department of Energy, and we had seen emerging successes in virtual prototyping there. We knew that this was feasible for multiphysics simulations that were going to be necessary. Now we have a figure, and I recognize that those of you who are just listening can't see this figure, but I'll describe it a little bit. The first part of it describes the more or less traditional 5 steps in conventional product development. And the big bottleneck is in the middle of this figure. It describes the use of physical prototypes, both at small scale and large scale, to reach a product. And this is a horrendous bottleneck because for a sophisticated system like an F-35, takes something like 2 decades to transit. That is, to get from the smallest scale to a full scale, a product takes a couple of decades. That is just considered totally unacceptable to the department. So we wanted to do something about it. And what we proposed was replacing that big bottleneck in the middle with virtual prototyping, where we replace these physical prototypes with software and supercomputers and virtual prototypes to do the design and testing. And it had the advantage of being dramatically faster and dramatically more comprehensive. We could do hundreds or even thousands of designs, test them, analyze them, and not just a handful that might be possible with physical prototypes. So this is the heart of what this is all about. And our challenge back then was to figure out how to actually create the software for virtual prototyping of the systems that the Department of Defense was interested in. We felt qualified to do that based on all our experience. Both of us have more than 50 years experience. And our original proposal was accepted, and it's been funded now for the last 16 years.
All right. And so I want to, one of the things I want to say here is that the physical prototypes have always had the limitation of their custom to a particular setting. And one of the things that we appreciate about the virtual prototypes is their malleability. And once we understand the physics and have that modeled, if that's the 1,000 design possibilities, if we actually have that malleability to be able to do that. So it really expands our trade space and allows us to make better decisions as engineers much, much earlier than when we're trying to work in the physical space. So Doug,
that's exactly right.
You want to add some into this and talk about your perspective on it?
Yeah, for us, this was the prospect of doing this was sort of the capstone of our career in terms of that, because it was a huge opportunity for us to apply what we had learned over 50 years of experience to take a program. And so the challenges were things like how do you put a proposal together, get it funded, and then how do you execute it? And so when we did all of that, we thought, well, that now that we've learned these things, we have this great program going and new people coming in, and they're going to look and say, how did it get started, and this sort of thing. And so we wrote the book to really document those lessons learned and to make them available to the general community at large. There were commercial examples of doing this. For instance, Goodyear Tire around 2000 was having trouble with their tire designs. They were losing market share. and so forth. And so what they decided to do was to try this idea of virtual prototyping. And they went to Sandia National Lab and got some help writing the codes to do this and so forth. And they were able, at the same time they were having trouble with it, with their tire design and losing market share, they managed to turn it around and went from making a new tire, doing a new tire, and instead of taking 4 or 5 years, they took less than 1 year. And so it just revolutionized their tire market, their ability to do tires. So the real challenges in this that we were beginning to face is how do you get, when you start these things, how do you get stable funding? How do you recruit and retain the right kind of people who can do this?
Right.
How do you get the right staff? And how do you implement agile methods for the government environment? We were finding that our experience in the DOE labs was really different than the experience we had in the Department of Defense. The Department of Defense is very rigid about things, rigid requirements, rigid processes, and so forth. And this is just totally incompatible with the kind of innovative development design, code development practices that actually work with real people who have to build real codes, because it's more like an innovative process.
And I want to point out just for a second, Doug, is that 2005 was only 5 years from the Agile Manifesto. So not only were you fighting DoD, typical expectations, but the methods themselves were, by many people, not considered to be proven yet. So, you had that in addition. You were in a very challenging time for making these kinds of changes on a very large scale and important program.
But what we had as an advantage is we had in our whole career, these were actually the kinds of methods that were being used by people who were actually getting a job done.
Yep.
Okay. Now that, of course, didn't matter to the Department of Defense. It had its rules. The Department of Defense is a large organization, 3 million people, billions of dollars, $700 billion budget every year.
Yeah, let me chime in and say that, like Doug said, DoD acquisition programs were expected to be like hardware programs. That is, they had a hardware mentality, and they expected software to conform to it. For example, planning was always long-term milestone plan-based, tracked by earned value management method. Well, we recognized that just wasn't going to work for us. We needed to be able to invent things and to be innovative. And you can't get there by a long-term, long-range plan. But we also recognized that our sponsors in the acquisition community would really be skeptical of us if we couldn't deliver. And so we had to concentrate on trying to figure out how to be able to deliver. We had other challenges, a lot of others that we describe in the book. I'll mention one in particular, and that is we found ourselves working with DoD R&D organizations which were not accustomed to creating what we would call production, quote unquote, level software. That is software that could be used by somebody who didn't write it. They weren't accustomed to doing that, and that made software engineering in particular a much greater challenge than it might have been otherwise.
So you've already said a couple of things about some of the insights that led you to agile software development as a foundation. And in particular, I've heard you say that you're driven by innovation in this whole program, and you can't schedule innovation, right, on a 3-year plan. And on month 9, I'm going to invent this, and on month 18, I'm going to invent this other thing. That just doesn't work. So Agile, we know, is very amenable to that kind of thing. What are some of the other things that led you to Agile software as the foundational method for how you wanted to do work? I'll start with Doug.
Okay, well, it's as we were mentioning, it's a creative process. And it's also one of the other standards problems that the regular Department of Defense program had is setting requirements. And in the case we were having to do, what you have to do, you can't really set requirements for things because it's a requirements discovery process. Software development is, you don't know what you're going to get. And so really what you end up having to do is to have senior management define the goals and the goals and where you want to get to, and then require, and then so let the and then push the decisions of what to tactical decisions of what to do down to the lowest level possible. The people who are developing the codes, because they're going to be the people who know more about what they're doing, and more about what the problems are, and are better suited to do the discovery process. So that you just can't develop software, as we were saying, with a top-down process. Another thing is the time scale for these sorts of things. Physical systems have very long lifetimes. The development of an aircraft carrier, it takes 10 years, 15 years to design it, another 10 or 15 years to build it, and so you just can't turn those things around. And so you've got to really treat it with a response. You got to match them to the scale of the task you're taking to do. Another thing is that the Department of Defense had this idea based on the hardware idea that you put together a design and you build it and then you're done. Okay, maybe there's a little maintenance, maybe there's a little, a revision later on, but, it's done, And so what we found with dealing with the Department of Defense was they kept expecting, when is the software project going to be through? And the real thing is it's never through, in a sense. If a piece of software is being used by a user to do a job, it's going to have to be constantly refreshed and upgraded and so forth to adapt. And the requirements are going to change. And so one of the great things about software is you can change the software to meet new requirements. And so it's never really finished. And this, of course, has been a major issue as the Department of Defense takes on more and more software. And the Defense Innovation Board and the Defense Science Board have really stressed the idea that software is immortal. It lives as long as you need it. And if you stop supporting it, it dies because, it rapidly becomes out of date. The computer systems change and then it doesn't work anymore.
So those are definitely things that we are living through on not just Create, but other systems. Richard, did you have anything you wanted to add into that?
Yeah. Let me add that one of the other things that we really focused on in Create from the beginning was the management of risk. Software development is an extremely risky undertaking. Failure rates in the literature are cited as 60, 70%. In particular, a recent Information Age article described a failure rate of 71%, with the upper end of what I just quoted. And Doug and I have done some case studies in the past in which we discovered that software very similar to what we're talking about in Create had a failure rate of 50%. It was a very sobering case study that we did, and it motivated us from the very beginning to try to manage risk. There have been billion-dollar government failures in software development. The FBI Sentinel case file management program was a billion-dollar failure, and so was the NSA Trailblazer software program. And when I say failure, I mean no working software after that investment.
Yeah. If you've been around the DoD a while, you've seen less impactful from a dollar viewpoint, but still very impactful failures. And the management of software risk is one of the things that seems to be a common failure mode in a lot of those. Or the lack of management. So you have all these experiences. You have been very successful in using these new methods. But being involved in adoption management for agile and other kinds of practices, I know that this was not an easy path for you. So talk for a minute in terms about things you talk about in the book related to the effort that you needed to implement this switch, not just for you've got the R&D folks that aren't used to building products. You've got the DoD seniors that aren't used to hearing things like, I'm not going to give you a 3-year schedule with, defined dates. lots of people, lots of stakeholders had to change the way they thought about and behaved in relationship to your project. So tell us a little bit about that experience. Doug, do you want to take that one?
Yeah, I'll take that. The most important thing to do that is to really recognize how hard change is. Okay, so you go and read a bunch of books about change. There are a lot of them out there about the problems of this. You look at Machiavelli is famous for pointing out that there's nothing as hard as change. You're going in and upsetting some standard way of doing things, and everybody's going to fight you because there's really no incentive, and no one else has any incentive to do anything because it's a big risk, and they don't really benefit very much from it. But if so it's really very hard. And so what you have to do is to really work hard to explain to people, get them to understand why you have to change, why they have to change, and what the advantages of all this. And you have to engender a certain reasonable amount of trust in what you're doing by the management. And it's really scary. So our experience in looking at the literature and so forth is it's easiest when an organization is facing an existential threat. In other words, if they don't change business the way they're doing things, they're going to go out of business. And that happened with Goodyear Tire. If they didn't change their tire development pools, they were gone. Okay, they were going to go bankrupt. And they recognized that. And so they're looking desperately for something to do. And a fellow named Suzanne Miller at Goodyear figured out computational modeling was a way to try it. And he got them, because they were facing this existential threat, he got a chance to do this. And he did it, and it's played off very well for them. And so the Defense Department is in some ways in a similar situation with airplanes, for instance. Up to 1975, it took about 5 years for a new airplane to come out. Okay, and the same was true of cars and so forth. But around 1975, airplanes got more and more complex, and it turned out it went from 5 years to 10 years to 20 years to 30 years. And if it takes 30 years to get a new airplane put together, the F-35 was an example. The Osprey was an example. Just that's too long. I mean, you pull out Augustine's book, and he points out in 50 years we'll be, we'll at the rate of the change, the rate at which the expense of airplanes is going, new airplanes is going. We'll in 50 years from now, the Defense Department will have one airplane a new airplane every year, and that will be changed. That will be shared between the Navy and the Marines and the NAVAIR and the other organizations, and that's just unacceptable. So we were that. So that's really you convince people that you have a better way of doing things, and that's become easier as we get into this. There have been a lot of quantitative studies done now that are now beginning to be published. The stuff was all very sensitive for a while because nobody wanted to own up to the fact that they just weren't doing a good job, that the place was really into. And now people are much more, it's become more obvious and things that were not. There's been a study published by the Hudson Institute fairly recently, described in our book, but you can also get it off their webpage. That points out that that the situation was really dire and is now getting much better.
And I would argue that some of that sensitivity was because in 2005 we didn't have confidence in solutions to these problems. Right. And one of the great contributions of CREATE has been to prove that we do have solutions to these problems. And once we have solutions, then human nature, once we have a solution, we're actually more willing to talk about the problem, is one of the things I've observed. So speaking of the success of CREATE, what is its current status? And to what extent has it been put into use by the DoD? That was the ultimate point, is to improve the acquisition, both the quality of the products we're building and the acquisition cycle. So Richard, why don't you start us talking about that?
Okay. First, CREATE has touched a lot of programs. It's touched at least 40 DoD programs of record with an aggregated budget of something like $50 billion. It has 2,500 users and customers in government, industry, and in universities. Now, 2,500 may not sound like a lot if you're Microsoft, but in our business, 2,500 users of a product like ours is a lot of users.
Yes.
It's almost everybody in the Department of Defense who could possibly use it. It's a lot of users. We're in our 16th year now. I think we're firmly established as a part of the Department of Defense's migration toward digital engineering. 16 years, by the way, is a long time for a software program in the Department of Defense. They're typically 3 years long. And we've managed to develop and mature, and I want to emphasize the word mature, 12 major systems, 4 for air vehicles, one of which is shared with the Navy for the design of ships, 5 for naval combatants, 1 for radio frequency antennas, 1 for ground vehicles, and a gridding and geometry tool that supports the whole Create family. So, these are not just in their infancy. These are quite mature now.
Yes.
And they have more capabilities than almost anybody, any one person could ever understand.
So that is very successful in our experience with DoD software programs, and the breadth of things that you've been able to do and I want to emphasize this: these are not, DoD business systems. These are complex cyber physical systems. These are hardware software systems. So you're really attacking the problem of the really expensive and long lead kinds of items. So that is something to be really proud of. Doug, I know you have some examples of.
So I'll just very.
I know this excites you, so let's talk about your examples.
This is well, it's really nice too, because you work with people who are very excited about what they're doing, and so you're working with the top level engineers and scientists at the Navy and in the Air Force and in the Army Aviation program. I mean, to be able to work with people who are putting together a piece of software that can calculate how a helicopter flies.
Yeah,
helicopters are amazingly complex, and we can actually predict. Those guys can predict how this does. For the examples of, I'll just quote 4 or 5 examples of tools. The Navy has got a new set of submarines coming out, both for ballistic missile launch and for attack submarines, a new generation that are coming out. And our tools are being used to design those systems, to measure their performance, to predict their maneuverability and seakeeping properties. We're designing tools for the new helicopters that the Army Aviation people are putting together. We're designing new helping. These tools are being applied to new fighter airplane like the F-35 and the upgrades of the F-15 and so forth, and they're even being used to design the parachutes that are guiding the dropping of cargo into active theaters.
Wow.
You want to go in and do this, and you want to design them so that they don't hang around. The airplane doesn't have to hang around trying to wait to find the right place, because people try shooting at it. So, and there's another example is they're doing upgrading the B-52, putting new engines on it and changing the aerodynamics somewhat, being used to keep the A-10 alive, which is it's a plane that provides ground support for the Army.
Yes. So let's talk a little more about the audience for this book. So some audiences are going to be interested in what Create has done and sort of how you managed to make these very complex computational models. But you also mentioned writing the book for people who follow you. Both of you are well deserved of getting into retirement and doing more fun things. So for those that are kind of taking Create forward and things like it, That's one audience. But who else do you think would be interested in this book? Richard, why don't you start us off on that one?
Yeah, well, of course, I think all along we intended it for engineers and scientists, that a broad category of engineers and scientists who want to take advantage of the power of virtual prototypes to improve their competitiveness. That is, we were inspired by the Goodyear story.
Mm-hmm.
They were trying to make themselves more competitive with this. And our hope is that it will help the readers plan and manage the shift to the virtual prototyping, establish and execute agile processes, manage the impact on development workflows. This really impacts a workflow,
Mm-hmm.
really changes a workflow. Verify and validate the software. There's several chapters in the book that touch on that activity.
Mm-hmm.
Recruit and retain the specialized workforce needed to do this. This isn't routine software development. And look for new opportunities. These are all things we hope our book will help readers get some insight into.
And I especially encourage readers who may not have seen themselves agile methods, lean methods being used in very complex engineering software. People have a tendency to say, oh, yeah, you can use agile over in the business side, but when we're dealing with these complex cyber physical systems, we have to go back to traditional systems engineering and waterfall methods and things. And I found that this is very inspirational in terms of saying, no, you don't. You have to change your workflow. You got to change some things. You have to work differently together. But it is absolutely applicable here as it is anywhere else. And I think you guys made a great case for that in the book. And I have people I'm going to be sending chapters to just for that purpose. So, all right. So we are talking sort of about the Agile and some of the things about verifying and validating software in this complex kind of interface. And one of the things that I think is notable about the book is that you're kind of looking at this process-bound environment like the DoD, but you're talking about some of the issues that you don't learn about in DAU and you don't learn about in engineering schools. And I think that's another, how to put a proposal together, get decision makers to pay attention to it. Those topics are not typical in textbooks. And so I'm curious as to what made you decide to write about those things. And Richard, I think you wanted to say something about that.
Yeah. Well, you brought up one point already, and that is that when we started this, there was no example game plan within our community of interest of engineers and scientists for how to turn up an opportunity for virtual prototyping into a successful program. We had nowhere to turn to see that. We weren't aware of the rather extensive literature in Silicon Valley for this. It's just not a part of what we were exposed to, as you pointed out. We weren't taught to do this. And so we felt like we needed to address that need. Chapters 6 and 7 of the book are our game plan for doing this in case you want to try it. And then, of course, the other big obstacle for us was the fact that the then existing program management and software engineering literature didn't provide any guidance whatsoever into how to cope with the hardware focused, I would really call it a bias, of DoD Instruction 5000, which is the document that governs the DoD acquisition world.
Yeah. And you were under what was called 5000.2, which is
right.
Which is hardware centric enough that they actually made a 5000.87 now exists since 2019.
Right.
It does address software, but you didn't have that.
No, we didn't have that. In fact, if you look back at the material available to us in 2005, there was really no distinction between software and hardware.
Yeah, you're right. Yeah. I remember the 2008 version started to kind of pull it apart, but you didn't even have that one yet.
Right.
So you are embodying a lot of lessons learned in this book. We've talked about lessons related to how do you get this thing going? How do you make decisions about it? How do you get change among the stakeholders? Doug, do you want to give us a few other lessons learned that you want to add into this list?
Yeah, well, let's see. That's the book really addresses what we thought was unique about it was it really addresses the practical issues. The not everybody who's in the business has gone to engineering or physics schools and graduate school, and they know how to do the technical details, but they've never really learned how to put a proposal together and how to deal with complex organizations and how to deal with how to get funding and the importance of pulling all of this together in a real organization. I mean, one of the things that I learned fairly quickly when I got there was John Bramer, who was the chief of staff at the SEI, gave me a book by Hugh Montgomery called Bureaucratic Nirvana, How to Survive in the Dip Box in the Pentagon. And it was a really very nice thing because he described it as kind of a cultural anthropology situation.
Yeah.
You had all these people in the Pentagon trying to maximize their own effectiveness and their own careers. Okay, they're all well-meaning and all trying to do a nice job. And none of them were really out to get anybody. But there was simple things in there like if you want to get your career, the way to do that is to start a new program.
Yep.
Well, to start a new program, you need money. Well, there is no new money, really. And so you got to take money from somebody else. So your job devolves from running a program and getting it established. Your job is to protect the money. And if you can't do that, you don't have a program. So because you don't have any money, you don't have a program. And so it's learning all these practical things. So it leads you into things like, figuring out how to get a proposal done, figuring out how to work with the financial people. Because the financial people in any organization are the people who really control, the management trusts them to make sure the funds available to that organization are spent to get the job done. And if you haven't got them on your side, it's a hard road. And so you've got to bring them in because normally, they're people who normally scientists and engineers don't really resonate with because, it's not the same sort of thing. But in point of fact, they've become some of the most important people in your life, in your professional life, because you need them to aboard and you need to get them to understand what you're doing and the value of it.
And to be able to communicate it. That's
they have to communicate the value to their management, who are relying on them to make that trust.
Yep.
To get that trust. And so that's an extremely important thing. And I learned that fairly early, thanks to John and his advice and other things. And so we were really, that was probably one of the most useful things that we did in putting Create together, was getting the Army, the financial people in our organization who were trusted to understand this. And then as life got on, it got more and more bureaucratic in the funding business because the government was looking harder and harder to do this. Having them on our side was just a wonderful thing. And that was really there. And you've also got to make sure you got to put an emphasis on establishing the value of the software to the people. And recruiting and maintaining software developers. That turns out to be an incredibly important issue. These people are precious beyond belief. There are very few people who can decide, who know enough about computing and aeronautical engineering to design an airplane. And if you've got people that are really able to do that and do it well, then you really want to protect them and treat them very well. And they're really the most valuable people in your organization. Well, everybody's valuable, of course, including the financial people, but a really talented, good aeronautical design engineer. If an airplane is not well designed, it's going to fall out of the sky.
Yeah, that's bad.
And that's not the right answer. And then finally, as we mentioned, verification and validation of the software is something you can never lose sight of. You have to keep working on that, because if you get the wrong answer, again, that's not going to be successful.
Yeah. And I also remember reading, you were very adamant about confronting risk and not letting risks fester and not letting them sit. And so say a little bit about that, because I think that's, risks are difficult because whoever raises the risk is kind of you get into a shoot the messenger kind of position. But if you don't deal with risks, then they manifest. And so say a little more about how you manage that.
Let me
I'll leave
let
that to
me
Richard.
yeah, let me try that
Richard
one.
was a hero in that area.
Yeah. Well, we were shocked, as I said earlier, when we did this study before Create started, and found that half of the software programs that we studied were failures. We had read the literature about this, and we knew that failure was talked about a lot, but to see it in things we understood was shocking. And so we sat down at the beginning of Create, literally the beginning. We asked ourselves, where are our biggest risks? And I don't know of any other program I've ever been involved in all these years where we did that as the first thing. We ask ourselves, where are we most likely to fail? Because we expected Create to live a long time.
Mm-hmm.
If it wouldn't be successful if it was not a long-term project.
Right.
And so we said, what is going to prevent that from happening? And we tried to identify the worst. Of course, we identified dozens, but we tried to focus on the top 10 risks. And there are things that are obvious in some ways, but people don't really focus on them and identify them at the beginning.
Right.
Long-term funding, that's an obvious risk. But if you're not constantly paying attention to it, you will experience it and you'll fail.
Yeah.
And there were many others. I don't want to try to recite them all from memory, but Doug has mentioned another one, the very important role that developers play in the process and how to keep them engaged. That's a big risk. Within the department, sponsor support is a big risk. Our sponsors are people who change jobs every 2 or 3 years. And we might have a new sponsor who is not at all sympathetic with anything we're trying to do. And in fact, wants to do exactly what Doug described, which is to capture our funding and apply it someplace else.
Right.
So these are examples of the kinds of risks that you have to pay attention to. Actually, technical risk is, I think, Doug can chime in on this, but it's further down the list. The ones that you have to worry about most are really not technical risks. We felt, because of our experience in the Department of Energy, that there was a handle on the technical risks.
Mm-hmm.
We had seen them addressed, and we thought we could do this. We didn't know we could do it, but we thought we could. But we didn't know whether we could manage these other kinds of risks like I've just described. So from the beginning, we identified them and began to try to address them and track them and mitigate them. And some of them are extremely hard to mitigate. We can't mitigate the promotion profile of managers in the Department of Defense. We can't really mitigate that, but we can try to work with the process and make sure that the people who are coming along know who we are.
Right.
So that's an example.
Good examples. And going back, I think the theme of this whole conversation is all of you good engineers and scientists out there, you're not going to be able to meet your goals unless you deal with these programmatic and socio-technical risks, is what I call them, the ecosystem that you live in. If you ignore that, then you're not going to be able to get your goals met. So even though it may not be your favorite thing to do, you're going to have to deal with it or find somebody to partner with to deal with it.
Right.
So, I definitely appreciate that perspective. So I want to switch over to a theme for our podcast, which is transition. And in the sense of, for people that are interested in learning more about the Create approach and the Create products, how should they get started? What kinds of resources are available in relationship to learning more about Create? And I'm going to, Doug, of course, and Richard, the book is kind of at the top of the list. But beyond the book, what are some of the things that they can look for? And I guess Doug or Richard, whoever wants to take that.
Well, I'll speak one thing. You doing these sorts of things, your developers, of course, are your real assets, but they're not going to want to do everything you want them to do. And one of the biggest resistances we found, or at least I found, was getting them to do documentation. They're writing this software, on this big, huge, complex thing, zillions of statements, huge programs, multi-physics, complicated mathematics, complicated physics, complicated computer programming, and so forth. And there's going to be turnover in this computer business. I would say we're lucky to have people in the same job for 5 years. And yet the program is supposed to last 15 or 20, and it's getting close to 20 now. And so how do you, the new staff, people come in, they look at this extraordinarily complicated airplane design program, and so what kind of document? They're going to have to pick it up. And the guy who wrote it may even not be there, and he certainly is not interested in holding the hand of somebody for a couple of years until they learn this thing. And so you really have to get people to do the right kind of documentation and pull it together, and they're not going to want to do it. And I remember that was one of the things that the groups were really very reluctant to take on until you convinced them that it was really essential. And it really, they had to document the code because it was in their best interest. So they had to put together a user manual because they wanted the code to be used. So they had to make it easy for people to use. Sure. And so they had to train the users and things like that. And if they didn't do that, then they were going to be on the phone all the time trying to tell somebody exactly how to use the code. And so you have to put together a test plan and let the users have the test plan and the test results so they can practice and practice at getting the right answer. Because getting the right answer is not just having a code that has been verified and validated. You have to validate and verify that the users can get the right answer.
Gotcha.
And so all of these things are really important. And the documentation is something that you need because you're not going to remember what you did 5 years ago either.
I don't remember what I did 5 years ago.
and especially in writing a complex code. And so it's got to all be there in a way that people can actually make sense of it and use it. And then it's, anyway, I'll get off my horse there.
Well, let me chime in. We have a slide. Of course, it won't be available to you if you're just listening here. But the Create developers and management have published a lot. There are 16 papers in the IEEE Computing and Science and Engineering Journal that you can consult for various aspects of Create. The various product development teams have been prolific publishers. For example, the Air Vehicles team has probably published something approaching 200 papers in the AIAA journals. The ships team, the team that develops software for naval applications, has published extensively in the ASNE journal. And the other teams have also published in various journals. As far as Create itself is concerned, it maintains a public-facing website that has a lot of information about Create in particular, and about the kinds of applications of this sort of software, virtual prototyping software. You can find it by simply searching centers.hpc.mil for Create.
Okay.
So there are lots of publicly accessible sources for information about not only the Create program, but the general concept of virtual prototyping, with many, many very specific examples of how the paradigm can be used in the literature.
So lots of resources, a lot of them self-serve. And so that's important. And over time, I imagine I would expect to see some of your work, especially now that you've got essentially the textbook, become part of the curriculum at graduate level, I would hope, so that people actually learn more of these things before they get out of school. But that we don't control that, so we'll see how that goes. So what is next for both you, Richard, Doug, and the work? Are you anticipating another book? Do you have other plans that are related to being involved in Create, or are you going to get sort of off of this stage and go do other things? So, Doug, I'll start with you, and then Richard.
I'm not sure we're going to write another book.
It's a lot
We
of work.
probably will be
I
happy to
know.
do a few more blogs and podcasts.
Okay.
Right.
Go into these things. We have, expand on, for instance, the stuff in V&V, to
Yep.
expand on the kind of documentation that's useful. Expand on actually probably the most important thing. Expand on how you deal with deal with the human dynamics of having a lot of very bright people working with you and for you, and how you treat them, and how you make them feel, or how you help them grow their careers, how important it is to help their careers grow professionally,
Mm-hmm.
and how important what kind of impact that gives your program and helps you recruit new people,
Right.
and so forth. Those kind of things that we think would be nice to do in terms of podcasts and blogs. But I've been looking through the book recently for preparing for this and other things, and yeah, it would be nice. We would write a somewhat different book, but it's an awful lot of work. I mean, we worked
I
on this
know.
book for almost 5 years,
Yep.
and
It
so the publication process it went fairly
Nobody's going to
smoothly.
fault you if you don't want to take that on again. Let me tell you.
And it's also both of us have 50-year careers, and we're now, I'm 77 and Richard's almost 80, so we're retired.
Yeah, you might want to do some other things.
Yeah, thanks.
Richard, what about you?
Actually,
What kind of?
I'm not retired. I'm still working with Create, and I hope I can continue it.
Excellent.
I'm their software engineering mother confessor,
Okay.
and
Okay.
and so I'm still engaged with the program and hope to be in the future. It's 16 years old. It's very mature, but it's also it's clear that it has a lot of potential. A lot of potential, and we've had many successful applications, but it's just the beginning. We're just at the beginning of this.
Yeah.
Doug and I were involved in programs in the Department of Energy, in software development programs that were 50 years old.
Yeah. Yeah.
Started in the 60s and still active, and
50s.
Yeah, 50s even, and still active. And so we hope for something like that for Create and other things in the Department of Defense.
Well, I think with the two of you shepherding this kind of content forward, I think that you're going to still have some fun with this. So I think when I get into my 70s, that's going to be kind of my goal. Is whatever I'm doing, it's got to be something that I want to have some fun with, and I see the passion in both of you for this. So I think the fun is still there, and as long as it is, we're going to get some great things out of you guys. Thank you so much for giving us this time. I do want to make a final note. We would like to thank the CMU Software Engineering Institute, SEI, and the DoD High Performance Computing Modernization Program for supporting the writing of this book. It is available from Addison Wesley at informate.com and on Amazon. That will be in the transcript. I am so pleased to have gotten a chance to talk with you. I don't know if you even remember me helping to facilitate a workshop for you back in 2008. So I remember some of those early days and some of the things you were dealing with, and I can't tell you how pleased I am at the success that Create has had and your ability to translate that into some really valuable lessons learned for our community. And I look forward to doing some more podcasts with you in the future. I do want to say that in addition to other published works, which we will link to, we also have, Doug has also authored a post about this work on the SEI blog. So you can go to our blog site, insights.sei.cmu.edu, search under Doug Post, and you should be able to find that. I do want our listeners to know that we thank you for joining us. If you can get to the video, you'll get some extra goodies from the visuals, and we will include links in our transcripts to all the resources that were mentioned. I think we might even be able to dig up your Machiavelli reference, Doug. I know where that one comes from. So I'm thrilled. Yes, exactly. I'm thrilled that we were able to have this time together, and I look forward to seeing what new ideas you come up with and new successes for Create and its applications. So with that, I will say thank you all and have a good rest of your day.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.